Yeah. So main agenda of today's webinar. So this is all about, see, I want to cover something about introduction on industrial automation and the products and features what are there in this. Different applications we are going to talk something technical which we did. So needs and demands, yes, needs and demands, potential and market analysis. Why should we learn and why core side? Why we should go into core side? What are our offerings and what are the other benefits we are giving and our credentials. So I'll just move to another slide. Yep. Yeah, automation. See, I want to give a basic definition about automation. Automation is derived from Greek word auto. Auto is self, like motion is like moving. So it's like automation is like self-moving. So it will move by itself. This is a basic definition of automation. So whether it is industrial automation or commercial automation or home automation or office automation, so that is not concerned. So automation is like a self-moving. It has to move by, it has to run or it has to move by its own. This is the objective of automation. So what is the benefits? A major benefits of automation is like higher productivity, yes, obviously, and superior quality and end product. With end product will be more good, and it is more fast and accurate. It is safe and secure. Now, so what are the types of automations? So I want to tell you there are different types of automations. So one is home automation and one is building automation and another one is industrial automation. Home automation, you know very well. This all CC cameras or CCTV surveillance and this door controls, lighting controls and this gate controls. All these basic controls covers under home automation. Now coming to building automation we are going to cover HVAC and all other CCTV surveillance and other things which is covered in home automation. Now coming to industrial automation, we are going to control and we are going to run all these industrial oriented machines and their process. We'll discuss more brief in the next slides. So what are the main benefits? Now today we are talking about industry. So let us take industry. What are the advantages when they go for automation? So when any industry, when they go for automation, the main benefits are their production will increase and their product quality will increase and the controlling of machine will become more ease and their safety level become high. So, and what are the other things? Their manpower will be reduced and their energy consumption will be reduced, their project timelines will be reduced and the raw material will be reduced. So these are the main concerns, benefits I can tell. Yeah. So before that, I want to give a small brief about previous history also. So in 18th century, it was entirely manual control. All these industries, all these manufacturing units, they were on complete manual control. The man used to do all the operations. Then from 18th to 19th, we upgraded to relay logic. We used to use some relays like contactors, some buttons, switches, this, that, all the stuff to make somehow a better control than manual. Then from 19th century, when you take 20th century, it is all logical controllers, I can say, whether it is microcontrollers or PLCs and different things. So all these are logical controls are now controlling industries. Yeah. Now, so what are the automation products or what are the automation topics? Okay. So the main topics or products is a PLC. We call it as PLC, Programmable Logic Controller, HMI, Human Machine Interface, and SCADA, Supervisory Control and Data Acquisition. VFD is Variable Frequency Drive, and then DCS is Distributed Control System, then Servo System. So we'll see all these topics in the next slides. Yeah. So this is PLC. I would like to make this session somehow a live session kind of thing, or a live demo session kind of thing. So let us make this session different than other sessions which you have. Yeah. So this is a call, we call it as PLC, Programmable Logic Controllers, where we have inputs and where we have outputs. Also we have communication connectivity and then we have a power connectivity. So whereas you can supply a power here 24 volts or 230 volts as an input to this PLC. So PLC stands for a Programmable Logic Controller. So it is helpful. You can connect all the inputs which are field instruments, we call it as. I'll also made some small demo here. I'll try to show you a live example how input can take and output will come. So we'll connect all field instruments. Let us take, you have a switch, you have a sensor and you have another push buttons and all. So all these devices we connect as a inputs we call it as field instruments. We connect to the inputs, and my outputs are connected to my motor or my indication lamps, something else. So this programmable logic controller, how it helps, it will take these inputs and see, we need to write a program into this PLC by using a programmable logic controller software. So where we have AND gates, NOT gate, NOR gates, all these basic logical gates we use, and it is like drag and drop software kind of thing, where you can enable timers, counters, and all stuff. So by using all those basic software, you can write a logic as per your need, as per the customer need. So when they connect some input, one sensor senses, then the motor should on. If that is the logic, then you should write that logic by using this AND gate, NOT gate, and with timer and help. So that this program will be sent through a communication cable via laptop. Via laptop, we'll connect one communication cable to this PLC as a communication so this is how it will work. I'll show you one live example here. See, I'll just tell you. See, this is a sensor. We call it as proximity. Are you able to see this? Is everyone clear with my? Is everyone clear with my video? Please type out if my video is clear. Video is clear. Please type out so that this is a very small object. I want to check my video is clear or not. Yeah, I'm just open. Yes, thank you. So I'll just bring this for you. See, this is a PLC we connected here. We have connected this device as an input. We of course we have given one MCB as a supply, and these are the indications, push buttons we have shown. Now I'll just activate this sensor by a metal device. See here, are you able to see this light? So when my sensor senses, my output has come. So we have written a program inside the PLC. When I'm touching this object, when I'm touching this sensor with some object, my output is coming. So this is how this PLC is functioning. Increase video size. See, while we are in presentation, we can't increase video size. I need to stop the presentation. I think that's going to be a challenge for other people. So it's just, I want to show. See, if any metal parts touches, then my indication will come. So this is input, this is output. That's the basic thing I want to tell. Yes. Yeah. Audio is not audible. Yep. I'll try to increase my voice. Yeah. I was just explaining about on the kit. Yeah. So what are the different advantages of PLCs? We can easy to do program, and you can modify multiple programs. You can write and you can change. You can write and change. In microcontroller there are limitations, so we can't write and modify time to time. And it is more reliable product you can use for many applications. You have from small range to big range we have, and then we have it is easy to erection and commissioning, easy to troubleshoot. It will show you all the errors, so it is easy to troubleshoot also. I'll just tell you some of the examples and applications I can tell. See, in cement plant, you can use PLC. In food and beverages, you can use PLC. All these areas, this PLC is everywhere, I can say. Here, this is a supply. This is a power supply where my HMI will get power, and these are my communication things. Through this communication cable, I can connect to my PLC. Then my PLC and my HMI will talk to each other. Then it will share the communications. So why this HMI? See, HMI is like a human machine interface. An operator, if an operator wants to stop the machine, he can't and he can't go into the PLC and start the machine time to time, or he can't go to all number of buttons or switches. So this will help an operator to interact with machine, to monitor and to control the machine. So this is for monitoring and controlling of the machines. So this will be connected to the PLC, and PLC will connect to the feed. So this is how. And we have touch screens, we have keypads, we have big screen. If this is the basic screen, we'll be getting 6 inch, 7 inch, 10 inch, 20 inches. We have big screens also available. So this is HMI. I'll try to show you one practical screen of HMI, because this session we want to make more practical at our level best. Can you connect power? Yep. This is one more PLC. We have one more HMI where we have connected this cables. I'll just connect the power. Yeah. So this is a yeah, and the power is on. So this is HMI. See, this is how you will get a screen. Yeah. Now see, we have designed a small screen because in this HMI the advantage is anyone can design a home screens and a start stop buttons, everything. It is all ready-made templates available in the software given that we have to drag and drop, and we have to give a addressing between PLC and this HMI. Then it will be, the communication has to be established. Yes. So this motor on off button, when I press start, see, when I press start here, then my motor will get start. See, when I press stop here, this is stop. So it's start and stop. It is again connected to PLC. Okay. So this is screen, start stop buttons. We can enable. You see here, when I stop, it is becoming red. When I start, it is becoming green. This is how the basic thing. Yep. So now I want to go to another. Yep. What are the different types of HMIs? HMIs are mostly used to control machines. One machine can be controlled through HMI. Like that, many machine applications we use HMIs. Then what is SCADA? SCADA is like supervisory control and data equation. So if you see into this image, if you see into the screen, we have shown some screen over here. SCADA is like supervisory control and data equation. See, SCADA is basically a software where that software can be installed into the PC, and this SCADA, through this PC, we can connect to the PLC by means of communications. So my SCADA is useful to control entire plant, whereas HMI is able to control a machine, but my SCADA is more scalable. So it is like the controlling will become supervised, and the data can be acquired and it can be stored into it. When you want to see the previous data of last 30 days production or last before day, when the machine was start, when the machine was stopped, what was the production count, what was the breakdown time, everything. So you can take all this history back and you can check. So you can generate reports, you can create trends, you can create graphics like how we have shown here. We are showing one tank, what is the level in the tank, and we are showing turbine, fan, pump and all. So this is all about SCADA. You can design all these graphics into the SCADA, and you can give addressing between PLC and SCADA. Yeah. So advantages. So it can reduce manpower because entire plant is going to control from one place. When if you people know about cement plant and power plants, the controlling room will be there. In that control room, all these SCADA systems will be there. So they can control entire plant through this SCADA. They can monitor and control and see the trends, what's happening, where something goes wrong, where it is goes wrong, what was the error. All these things, the SCADA is going to help us to give the information. So it reduces manpower. It is used to monitor and controlling from one place. Easy problem identification from one PC, one place. So the major applications of SCADA is we use SCADA in factory automation. We use SCADA in process automation. This is discrete, we call it as. Process means all this pharma, food and beverages, and this other power plants. And factory automation is cement plant and other industries. So, Parmesh, can you change my video to the down? Yes. Yes. So this is all about drives now. It's VFD. VFD is like variable frequency drive. I'll also try to show this VFD. Yeah. This is a brand called Siemens. I want to tell one more thing. Today in this meeting room, we have engineers from Siemens Hyderabad branch. We have Mr. Ram Sagar, who is look after drives, and we have Mr. Pavan in this room, who is look after automation. So those two people with Siemens Hyderabad branch support, we are conducting this webinar. So if you have any technical clarifications, then Siemens team is going to support us for all the technical clarifications, whatever we have. So those people are there in this room, they can respond to you. Thank you. Thanks to Siemens Hyderabad and thanks to Ram Sagar and Pavan for giving support to conduct this webinar. Yeah. So coming back to my topic, this is a VFD, variable frequency drive. If you see here we are going to connect power as a 3-phase input, and my VFD will get power. and this output of the VFD will be connected to the motor. So VFD is used to control the motor speed, direction, and remote access. So these are the main advantages of VFD, and you will also save the energy of motor. Whatever motor full load, the current it will be reduced when you connect through drive, because drive will convert AC current into DC current, and the DC based on the motor load, the DC again converted to the AC, and it will be given to the motor based on the end requirement, based on the load, I can say. So that the motor won't always take full current, thereby your energy is saved. So this is the advantage of VFD. And we have on off buttons. You can see the display here. What is the motor current, frequency, power factor, speed, all these parameters are can be seen through this VFD. And you can connect PLC through this communication cable, and you can control through HMI and SCADA this particular motor and drive. So this is how the drive is going to help us. So we have AC drives, we have DC drives. So we have these two category for all AC motors, AC drives. For all DC, we have a DC drives, and we have the advantages: energy saving, speed control, direction control, and harmonics reduction. I'll tell you one application examples. So we have shown here a regular basic application, because most of the people are from academics here. So I want to make them more realization. So when you see these elevators, my VFD is going to control this elevator speed. When you want to control at accurate speed, it will stop at particular floor and it will slow down. So all this start, stop, and speed increase, speed decrease, everything is done by VFD. So VFD is the best example for this elevator application. And second application, if you see to second image, this is a office building, I can say office building. So if you see all that white color boxes, all these are VFDs. 1, 2, 3, 4, 5, 6. One building is having 6 VFDs to control their heating, ventilation, air conditioning, HVAC. So all this air, all this floor temperatures, everything is controlled through drive. My drive will run that motors. It will increase and decrease the speed so that end temperatures are maintained well. So these are the two regular applications. And now coming to servo, we have servo. We have servo here. Servo is a combination actually. It's motor and drive always. So this is all about. This is a servo. Yeah. This is a servo motor, and this is a servo drive. So when you see this, it is all together. So my servo, the difference of induction motor and this motor is like, so we'll be having two cables here. One is power and one is encoder. So this is a power cable, and there is one encoder cable. So this two cables are given on this servo, because see, this servo is like a permanent magnetic motor. This shaft is run between two permanent magnets. The accuracy of the servo will be more. These servos are used in CNCs and robots. So all your robot arms are connected through this servo only. So this is more compact one and accurate one. And this is a combination, as I am telling, servo is a combination. So it will be connected, that power cable will be connected here, and the communication cable is connected here. And my main power will be given to the drive. So my drive will run servo. So this is how it is two-way interconnected. And my servo is having an encoder on this shaft. So however it is rotated, my encoder will give time to time feedback to my drive, to my PLC, and to my HMI. So what I want to tell here is, the motor, whatever direction, whatever rotation it is taking, time to time will be getting feedback through this encoder. So the feedback system is a benefit in this servo. Whereas in induction motor, the feedback system is very less, very low, I can say. But here the integrated encoders, different types of encoders we have, absolute encoder and incremental encoders, kind of thing. So where we can get more accurate data. So because it is used for accuracy, and it is used for the advantage is like high low moment of inertia, high overload. When you have given high load, but the speed should be low, then also it is going to run. So high resolution encoder, the fast scanning time will be, and motion control functions are inbuilt. Positioning, you can do positioning like pick and place or one position to another position, and feedback system is there. I'll give you the examples. So these are the two examples. The first one we have shown a CNC cutting machine. Second one is CNC milling machines. Why we have shown CNC only means the servo is most of the times used in CNC and high accuracy applications. So these servos are help us to give more accurate the speed if you take, the direction if you take, or the load and the controlling power and the feedback system. All these are very high, and it is most of the times used in accuracy applications only. So cutting and CNC, these are the some applications. Now coming to DCS, some people might be heard about DCS. So DCS is like advanced system than PLC. So PLC is like going to control certain number of IOs. We have to write program for each function. But whereas in DCS is like a plant level control. So you can control entire plant by means of a distributed control system. So this distributed control system, if you see this slide, so we have shown 3 controllers, and the main distributed controls are again all these bottom PLCs, second line PLCs at different sections. Say suppose fans and this furnace and this machine conveyors, all these different kind of PLCs, different kind of sections are connected to the DCS. My DCS is going to drive the plant. It is going to monitor all the PLC's data, and it will give a main data and main controls to the management level at main level or a control room level. So it is like advantage is there are some ready-made function blocks available in the DCS. For each function you need not to write a program. The ready-made function blocks you can take and set of IOs you can connect to this function block, and this function block will monitor that particular IOs and will give the statistics to the SCADA. So by which you can reduce the time and you can control more PLCs, more number of IOs, and your controlling system will become more ease. So this is all about a DCS. Yeah, applications of DCS, most of the times pharma plant and power plants. So all these areas we use DCS. All the process industries, I can say, all the process industries require DCS for having better control and a safe control. Yep. So yeah, robotics. See, some people are typing some technical comments. I don't want to hold on and answer these comments now. I'll just take 5 minutes time at the end of technical session, or I'll spend 10 minutes. Then we'll answer all the technical queries. Kindly bear with us. Meanwhile, my team will answer to your queries. I'm not holding on these comments. Kindly excuse me. I'll just hold on for certain time after my session, and I'll clarify all the technical queries. Yeah. Now this is robotics. The interesting one you need to know, and we are also need to enhance our knowledge on this robotics and servo, and for the future ready, we have to understand all these things. Now, how this robots, what is meant by robot? Most of the people might be knowing it is like a machine controlling a machine. Means it is completely operated and driven by the mechanism only, mechanism or machine. So robotics, I can tell. See, first of all, this HMI, PLC, all these things, man involvement is more. But whereas in robo, you need not involve any man or operator. Once you program it everything, and you fix certain application or something, you write a program and you can set it. So it will pick and place, or it will rotate, it will do welding, it will do cutting, it will go to the certain place and it will hold on. All these applications it will do by itself. So we'll be having multiple axes in the robo. So say suppose this is 1 axis, 2 axis, 3 axis, 4 axis. Like this, different axes can be programmed at a time, and the synchronization levels will be very high in robot, and it is completely a without human intervention, the applications and performance can be done. So main thing, the robot, where the robots are used, wherever the hazardous areas in an industries, wherever the high temperature zones, wherever the very low temperature, -degrees, where human cannot do any operation, there those cases mostly robots are used. And of course, some high-end applications, 24 hours functioning applications, these robots are used, and where you need more accuracy also, robots are used. So these are the main areas where robots are used. So it is safe and speed, and it is consistent, and the perfection will be more. It is productivity will be more. Your job creation and everything will become more easy. Your efficiency will be increased in the plants, and improved quality of the end product. So this is all advantages of robots. So by the way, see, this is our factory picture. We have a robot installed in our factory. We are having manufacturing factory. I told you, Vedan Infant projects. There we are doing aluminum panels welding, which is used for construction industries. Sorry, construction domain. Those aluminum panel weldings, we are using this robot. The robot will work 24 hours, 2 shifts, 3 shifts, and it will do welding. So this is our plant pick. So we can do different programs on the robots, and we can explain to the people. Yes. So these are some robotic application. The above picture is showing like pick and place. The water bottle, it is food and beverage, and the second pick is showing like 1, 2, 3, 4 robots with 5 axes is 20 axes. 20 motors are working at a time and having good synchronization, whereby the welding the spot weldings are done on automobile industry for a car. So these are the second application. So you see the accuracy and the synchronization level. 5 robots into 4 motors, almost 4 to 5 motors. So 20-25 motors are working parallelly, and it is with no clash, and the productivity will be high again. So these are the best examples of productivity and accuracy and motion control and all. Now, see, the topic is machine safety. Machine safety is like, yeah. So nowadays, people are now realized, and people are now giving more importance to the human lives. Yes or no? So yes, yeah, yes. So because an operator or a human lives is more valuable than the machine, than the asset, or than the production. So nowadays, machine safety is a prime concept or prime to reduce the accidents or errors in the production lines. So this particular machine safety, I'll just bottom. Yeah, yeah. So yeah. So this machine safety, there are some universal standards. We call it as in ISO 13849-1 is a machine safety standard. What we are discussing in this slide is machine functional safety, because if you tell about safety in industries, there are many things. So now today we are talking here about a machine functional safety. This is called functional safety. When an operator working on machine, he should not injured by his finger, hand, arm, and body, and that thing. So there are different types of safety measures we have to taken care on the while working on the machine, while manufacturing a machine, while producing a product, or while maintenance. These are the 3 areas where the safety is a big concern. So where this IEC 62061 is one standard we have, and ISO 13849-1 is another standard for machine functional safety. So these are the 2 standards, what they tell in that standards. So if you take screenshot of this screen and you can type out ISO 13849-1, they can give big list of standards which we need to follow while manufacturing machine, while doing production, while making machine maintenance. So there is a PL, we call it as, and SEAL, safety integrated level, and we have IEC standards, we have ISO. All these things are used to implement safety on the machine. So when you stop when you stop emergency, the machine should stop. So this emergency stop and stop, push buttons, all these things to be a safety product. Then only it will stop at safe condition when something goes wrong. This is a basic idea I want to tell. So safety is a big concern, and it's very important nowadays. Now, second is instrumentation. See, instrumentation is a very key role in automation in industries, because see, all these topics, whatever we have discussed, PLC, HMI, drive, SCADA, Servo, all these things are controlling products. But what are the field products? All these instruments are field products. Your sensor, the first one is sensor, second one is a limit switch, third one is a level temperature sensor, and we have level sensor, we have valve, and we have pressure sensor. See, this is one sensor. This is the first one what we have shown. This is we have inductive type, capacitive type, both we have, and we have a temperature. We have a temperature controller. This is a level sensor. Sorry, when you put this level sensor into the tank, you can measure the level based on the water level. This particular knob will go up and down, and through this electrical circuit we can take the signal. We can take the signal through this electrical circuit, and it can be connected to the PLC, and your PLC or HMI will show the levels. Your PLC will take the signal and it will show it on the HMI or SCADA. Based on the level, you will on and off the motors. So this is how these field instruments are useful. So all these field instruments are connected to the PLC as an inputs, and few of the field instruments are connected to the PLC as outputs. Both these inputs and outputs can give field status to us. So these are the main things. Yeah. Now, this is very interesting. Actually, I can tell this is the main slide of the day. So this is Industry 4.0. Now we want to talk something about future trends. So today we are here to discuss about this future trends. We want to put a light on all of our minds about this slide. So now, see, if you see this slide, we crossed first generation, second generation. Now we are at third generation. In third generation, first generation, it is completely manual. Second generation is a mass production, is a primary concept. And in third generation, which is 20th century, it is of course through automation and through computing. But the sad thing is, like, we are not fully utilizing automation and controlling system and computing even at current situations. So some people are still following a manual methodologies, and they're not unable to upgrade to the latest technologies. But the market needs, demands has grown like anything. The population is also growing everywhere across the world. All these needs, demands, accuracy, productivity, remote controlling, all these needs has been increased. So to fulfill these needs, obviously we have to upgrade to the next level, that is fourth generation. We call it as Industry 4.0. So in 4.0, what are the main things? If you see into this right side, the 4.0 will be more of a cloud computing. All our data is to be not stored on the physical devices. Now we are going to store on clouds. So this is one thing. And mobile technology, through mobile you need to operate your machine. Sometimes your plant control also is required to be done through mobile. This is one need. And we have machine to machine, is like artificial intelligence. So if you take one robo will do performance, and this robo will send signal to another one to you perform this. Then this will give I performed it, and you go to next level. All this machine to machine talking, and the feedbacks, then according to the feedback, the changes, all these things can be done through this machine to machine concept. And 3D printing, nowadays you people might be heard about 3D printing. So this is like objectives we will be programming in that, and all this equipment will be get ready. So when you make the objectives and when you do programming, based on that, the output will come with required raw materials. This is 3D printing. And advanced robotics. Advanced robotics, like, see, the robots are going to be an artificial intelligence enabled, and it will talk. Once you give the programming, it will understand itself and it will perform the next step. So it is like advanced. And big data is like analytics. We have to see the analytics, what's happening when the machine is performing at high range or low range. What all the statistics can be done in an analytics. And Internet of Things, it's like all field devices we are now taking into a remote network connectivity, so that your hardwiring and physical presence and this hardware is getting reduced. And this RFID technologies, it is also again remote, through a Wi-Fi network, or through a wireless. I can say through a wireless we need to catch the signals and we need to respond. And cognitive computing is like we have to make all these networkings and all together to make the system controlled by the computer. And then cyber security is a main topic. Cyber security, when you go to cloud, when you talk about all these things, the cyber security is a key role in an industry, because the data is more valuable. So this security is more important. So this is all about 4.0. It is a future, I can tell. In the future, all these things we need to learn. We need to enhance our knowledge and skill. Then only we will be future ready to get into this vast domain. Yeah. Now, Internet of Things. Yeah. Internet of Things is IoT. So this IoT is like, you see, when you have a device, hello, yeah. So when you have a device in the plant, so nowadays what we are doing, all these devices we are connecting through a hardware. So now this Internet of Things, how it is going to help? So we are going to connect a network gateway or a modem. So all these field instruments or your field devices can be connected to this modem, and my modem will send entire data to the remote area by means of wireless. So this is all about IoT. So what we are making entire field instruments to the main device, which is gateway, and this network gateway. This network gateway will connect all these devices, and it will send signal or data to the remote areas. Okay. So this is all about IoT. Yes. Okay. So this is all about industrial Internet of Things. See, industrial Internet of Things, like in an industry, generally IoT is like remote connectivity to a network gateway. But industrial Internet of Things, like connecting all these industrial signals, are connected to this network devices. Yeah. Now, this is potential segments. There are many potential segments into automation. Main thing is we have factory automation and we have process automation. So just on my video. Yes. Yes. Is everything okay? Thank you. Okay. Now these are the potential segments. What I want to tell. So factory automation and this. Yes, process automation. In factory automation, we have cement industries, we have packaging, and we have paper, we have rubber, we have textiles, we have metal industries, we have automobile and end use. So in process automation, we have pharma industries, we have food and beverages, and we have power plants, we have chemical, oil and gas, water. So here I want to tell one thing. See, before coming to this webinar, I have just gone through what is the industrial industrial automation market. This is the one survey I have got in the web. So this is done by Fortune Business. Automation market is, see, the automation market size, so that you will understand what is the size of the industrial market. It is almost 168.81 billion USD in 2019, and it is expected to grow by 8.9% by 2027. That is around 326.14 USD billion dollars. So this is a very big industry network. Opportunities we have when you have knowledge, when you have skills on all these topics and products. So we have different opportunities: automation engineer, programming engineer, design engineer, service engineer, technical sales engineer, sales and service engineer, automation maintenance engineer, sales coordinator, service coordinator, project engineer. All these areas we have opportunities. So where you can learn, where you can get opportunity, we have a huge scope. And we have scope into innovations. You can make your innovations live. Automation and products. So R&D. If you have knowledge about this, you can also help in R&Ds as a control engineer and system engineer and product developer, etc. Yes. So here I want to stop, and now I want to answer few technical queries. I'm just now